Good morning, everyone. Sorry, a bit of a slow start this morning. Hope you're all okay though out there. So, where are we? We're on Friday, end of the week, and next week we have got plenty coming your way. Some GCSE stuff from Michael. Michael, by the way, is doing the live chat this morning, colleague of mine. He's from Air Maths Tuition, so he's running GCSE live streams next week on Monday, Wednesday and Friday. So hopefully if you've got brothers, sisters out there that you can join him for that. And I'll most probably take over on the live chat. So Michael's here then on the live chat this morning to answer your questions if you're new to this. If you're one of the regulars, good to see the regulars out there, then you know what we do. Be about 30 minutes this morning. I've changed it a little this morning. I said I was going to do exam questions. I'm just giving some shorter questions today. I think they were a bit too long during the week. That's the kind of feedback that I'm getting. So going to make it a lot shorter today. So hopefully we'll get some quick responses from you guys. Okay, usual thing, just put your answers in. I'd encourage you to have a go. It doesn't matter if you get them wrong. It's just the fact that you have a go and not afraid to put your answers in. We welcome answers, okay? That's the name of the game. So it's pure maths today. I'm going to be looking at some coordinate geometry, tangents, normals, area under graphs. What else can we say? Intersection of graphs. And we'll also be doing a bit of differentiation, take you through the quotient rule. If you're not sure of some of these ideas, don't worry too much. I will give you clues on the way and the odd formula. Okay, so I see that most of you are on at the moment, so grab your pen, paper, calculator maybe. I don't know whether you'll need a calculator so much today, but we'll go for it. All right, so let's kick this off. Okay, good luck guys. Okay, chat to you at the end. Okay, so here's our first question. Typical kind of question you're going to get on an exam paper. But I've taken out a lot of the, I'm going to give you a lot more of the stages in this one, okay? So what I've got here basically is a curve. This equation is y equals x squared plus 1. Keep it nice and easy. We've got a normal here at this point A where the x coordinate is 2. And the first question I'm going to ask you is to tell me, let's bring it up here. Whoops, gone off again. Okay, here it is. What is the gradient of the tangent at A? So see if you could tell me what that is. Okay, what is the gradient of the tangent at A? If you could just enter that in when you've got it, that'd be really good. Keep these questions nice and short today. What is the gradient of the tangent A? Right, they're storming in, okay, with some answers here. Okay, are they correct? We seem to see 4 coming in quite a lot. Yeah, dead easy for you guys. It's the method that I'm really interested in here that I'm teaching today, okay? You're right, it is 4. And to get that, okay, what you got to do is just think of the tangent, okay, to the curve at that point and work out what that gradient is in general by doing dy by dx. dy by dx is 2x. That gives us the gradient of any tangent to this curve at any point x, as I'm sure a lot of you guys know. And we just need to substitute x to get that particular gradient today into here, and if you do that you're going to get that answer that you guys all said. X equals, oh sorry, not x equals 2, when x equals 2 the gradient is 4. Okay, Always handy, by the way, just to check with a sketch when you do these things, if you trip up, okay. If I got a negative answer here, I would know that it's going to be wrong because negative gradients would be on this side of the curve, okay, going downwards, we're decreasing. Okay, so it doesn't necessarily mean you're right when you get a positive one, but at least you know you're on track, you know, it's not going to be a silly answer. Okay, what's the next question? I just summarised, by the way, we've worked out dy dx is 4, but the question was, what is the gradient of the tangent A? So it's always a good idea just to summarise at the end. Gradient of the tangent A is equal to 4. Okay, here's the next one, part B. What is the gradient of the normal at A? That should be really quick, okay? What is the gradient of the normal at A? Okay, Gary coming storming in with his answer. Anybody else? Okay, yeah. Good. Okay, Bushy is coming in with -1/2, but the majority of you are coming storming in with -1/4. Great stuff. Okay, it is -1/4. Remember that the product of perpendicular gradients, and normal is always perpendicular to tangent. And when you've got perpendicular gradients, the product of the gradients should equal -1. And it's very easy, really, just to use a simple rule that to get the perpendicular gradient, just switch the sign that you've got here, in this case 4, so it would be -4, and then reciprocate it, which means put it underneath 1. 1 divided by -4 gives us -1/4. So that gradient of the normal in part B will be -1/4. Okay, so perpendicular gradients. Right, okay, moving on. Okay, what is the equation of the normal at A? Give your answer in this form: ax plus by plus c equals 0. Okay, so give us the gradient of, not the gradient, the equation of the normal in this form. Okay, let's see what answers we get. Normally, when you get questions like this, it will finish off with where A, B and C are integers. Okay, so go for that. I didn't really have much room here. Where A, B and C are integers. So express it in that form where A, B and C are integers. Okay, keep going. We've got some answers out there, varying though in many ways. So let's see if we can get some more answers coming in. Okay. Let's just hold on for another 15 seconds, okay, and see how we get on. Remember the form I'm asking, okay? Ax plus by plus c equals 0, okay? A, B and C I'd like to be integers, okay? Right, so there's varying answers coming in. So who is correct? I can only really see at the moment one person who has there's a couple of you who have actually put answers in the form that I'm asking for. Okay, so if it was an exam, you've got to be careful here. You've got to make sure that you answer it in the form that they suggest. Okay, ax plus by plus c equals 0. Okay, let's bring up the answer. Okay, how we do it, and we'll see who was correct. Okay, first of all, okay, we need to get a y coordinate at a. That's very easy. You just need to substitute x equals 2 into y equals x squared plus 1. Hopefully you all got that. That was the point A is 2, 5. Now, when you're working out the equation of a straight line, in this case, the equation of a normal, okay, still a straight line, you could use y equals mx plus c, but it's so cumbersome that when you have actually got a point on the line, 2, 5 in this case, we have the gradient, it's minus a quarter, and the best form you could use is this form, the one that goes y minus y1, being the point 5, equals the gradient minus a quarter times all of x minus x1, which is in this case 2. So this is the equation of a normal. If it said find an equation of the normal, this would do. But we're going for this form here. So if a, b and c were integers, I want to get rid of this 4. So I'm going to multiply throughout by 4. And if you do that, you're going to get this result. 4y minus 20. This is going to just be minus 1 then times all of x minus 2, which is going to give you minus x plus 2, and you need to rearrange it into the right form, which is x plus 4y minus 22 equals 0. And I can see up here lots of different answers. Some of you guys got it right. I think, if I'm not mistaken, is it Iggy who gave the first correct answer? Correct me if I'm wrong, Michael. Okay. But well done to all you who got that, okay, or even nonetheless got it right in a fashion where it wasn't quite rearranged correctly. Okay, so I hope you can see your way through that one. Right, and by the way, it was interesting to see how one of you, I noticed it's gone through now, I think, but one of you anticipated what the question was going to be about, which is always a good thing when you're looking at exam questions or questions, is if you do enough questions, you will find that you will be thinking ahead of the problem. You'll say, oh, this is familiar, I know where this is going. So practicing so many of these questions is definitely of benefit. Okay, now let's just move on with this question again. Okay, what I've done is I've copied down the diagram and updated it with the stuff that we've already found out. We know that A is the point now with coordinates 2, 5. We've got the equation of the normal, x plus 4y minus 22 equals 0. And on that point, you most probably might be able to forecast what the next question might be. Any ideas? It'd be interesting. Let's just throw this open. Type in what you think the next question might be. This idea of anticipating what's coming up. Anybody? Yeah, exactly. It's going to be to find this intersection of the normal with the curve. In other words, to get the coordinates of B. So there it goes. I'm going to put that question up for you. Find the x coordinate of B as opposed to the pair of coordinates. Okay. If you want to give me the pair of coordinates, fair enough. But I'm looking for the x coordinate of B. So away you go. Shouldn't take you, well, it might take a little while, not too long. But Iggy, you say you already have it. Just hold back just for a moment if you can. But well done. Okay. Hopefully it won't spoil it too much if you just hold back for a short while. All right. Okay. So we're looking for the x coordinate of B. Okay. the x-coordinate of b. Mr. Bowles coming in with an answer already at -9/4. Is that correct? Let's just see some other answers. Have a go. Okay, Raja coming in with -9/4. In the past, if you've been at these workouts, quite often we do see quite a lot of answers that are the same, and then somebody else comes in with the correct answer. It doesn't necessarily mean it's right if you all come in with the answer. In this case, -9/4. Is it correct? When you're finding intersections of two lines, a line and a curve, two curves, it doesn't matter what you're finding the intersection of, it always is in simultaneous equations. So you should be heading down that way, looking at simultaneous equations. Okay. Right, well, let's just move on then. It is -9/4, -9/4. So well done, guys, for getting that and sticking at that. Let's take you through this just in case there was a problem out there for any of you other guys. What we need to do is set up our equation at B. We're looking at B, okay, and we would need to do simultaneous equations. Because of space here, I'm cutting this a bit short, okay. What I've done is I've substituted x squared plus 1 into the equation of our normal for y, okay. You can see that I've replaced the y here with x squared plus 1, okay. This is called solving simultaneous equations by substitution, okay. So that's what we're doing here. And so what we've got here is, I can see because we've got the x squared term, it's going to head down towards a quadratic. When we expand the bracket, we're going to need to rearrange it, okay, and so on. So if you expand it, you're going to get this line, okay. Need to put it in the form ax squared plus bx plus c equals 0. So if I do that, this is my quadratic equation. Normally these things factorize. You can get clues, by the way, if you've got to use the quadratic formula. If you've got an exam question, quite often they might say give the exact value in surd form or something like that. That's going to be the formula. This one just is straightforward. It does factorize, and it's a good idea just to bear this in mind, by the way. Although this is an easy question, there are some hard questions out there, but you can gain some tips here. We already know that one of the coordinates on here, the x-coordinate at A, is 2. So that means that for this, x equals 2 must be one of the solutions, which really means, by the factor theorem, that x minus 2 must be one of the factors. Okay, if that means anything to you guys out there who have done the factor theorem. Okay, so I know already that one of those brackets must be x minus 2, which would lead us into x equals 2, this coordinate, x coordinate A. Okay, so if you put that bracket down first, very easy to work out what the other factor must be, in this case 4x plus 9. Okay, you can check out that expansion, it will give you that up there. So in the usual way, put each factor equal to 0 and solve each one. We know that x would equal 2 from here, but here's our x equals -9/4. That has to be the x-coordinate B. Again, having the graph here, just in case you tripped up and wrote 9/4, for instance, when you're doing it quickly, you can look at the graph and see that it's got to be a negative value. Okay, so always handy to have as a guide. So in the end then, we know that x equals -9/4 at B. All right. Okay, so let's just move on. We've got another question, one more in this section. Again, I wonder if you guys could guess what that question is likely to be. Okay, again, this idea of anticipating a question. Okay, let's see, can anyone anticipate what the next question is going to be? Just give you about 15 seconds, okay, just to give me an answer if you think you know. Find the y coordinates coming up. Yes, it could be. It's not though, but well done if you did work that out. Just simply a case of putting minus quarters into the equation of the curve or the equation of the normal. You'd get your y coordinate there. The length of AB, yes, you could have that question. A little bit of Pythagoras theorem in there. Distance between 2 points, good one. Ali coming in with find the area under the curve. I like that. Find the area under the curve. Bit of integration. Okay. Maybe the area trapped between the curve and the normal. Okay. Well, I'll put you out your misery. Good to see, though, what you're anticipating a question could be. I like that. Okay. Well, I'll tell you what it is. It is basically about area. You most probably could have guessed by the introductory sheet, okay? It's going to be on area under the curve. Be careful though here. I've tried to make it quick and simple for you guys, okay? And that is, find the area bound by the curve between the y-axis, the line x equals 2, and the x-axis, okay? Should be fairly quick. It's just to get you used to the idea, okay? It's the method rather than being a complicated problem, okay? So there we go. I like that idea from Papua 002, finding d2y by dx squared, by the way. Yes, we could have done that one, okay? But our questions are trying to follow on. Okay, so we're looking for that area. Give us an exact fraction if you can, please. Okay, and it'd be interesting to see what you write your answer as. Okay, I'll give you a clue. I want you to find the area bound by the curve between the y-axis and the line x equals 2 and the x-axis. Okay. Mr. Ball's coming in with 14/3. All right, anybody else? Okay, right. 14/3 coming in. Okay, someone was listening to what I said. Good to see though that you're taking part in this. Okay, anybody else? Gary's coming in, Paul's coming in. You're all coming in with 14/3. But I did say I'm going to be very strict on this one. Okay, I like Sean's answer. I'll tell you why. It is 14/3, and you would get the marks in an exam if you did have that as your answer, 14/3. But strictly, it is an area, and if I was examining you, I would ask for it to be units squared. All right, but that's me being very picky. Okay, let's take you through this in case you didn't know. Okay, I was kind of trying to trip you up a little bit as well. I thought you might anticipate very quickly that it was going to ask you for the area between B and A under the curve to the x-axis. Okay, it just meant the question would be longer. It's between the y-axis, which is where x is 0 and 2. So you're going to need to integrate x squared plus 1 with respect to x between x equals 0 to 2. Okay, going from 0 to 2 in that order. Not from 2 to 0. Never say it like that, by the way, going from 0 to 2. And make sure you've got brackets around those two terms when you're integrating with respect to x. So it should be very easy. Just integrate x squared. You're going to get x cubed over 3. Integrate the 1, you're going to get x. So there it is there. If you integrate it, you've got to put it between those limits, 0 and 2. 2 goes in first. Subtract what you get when you put 0 through. When you put 0 through, you're going to get 0 anyway, so it's just a question of putting the 2 through. And if you put the 2 through, there you go. You end up with 14 thirds, okay? 14 thirds, but because it's an area, I always suggest, okay, that you should, or encourage you to put square units on the end, okay? So let's move on. Okay, by the way, you could have a volume here for something or other. If any of you guys done volumes of revolution, your interest might relate to a volume, so you could say, you know, units cubed or cubic units, or it might be centimeter cubes. Answer it in the context of what the question was. Okay, right, we're going to move on. Well done though for taking part on that one. And last question now. Now this one is not going to be lots of parts. It's just going to be one question. If you saw the intro, you'll most probably know what it's going to be about. Okay, it's on differentiation and it's going to be on the quotient rule. I've given you a very easy one here. It's just the method. And I'll put up the formula for you guys if you're stuck in a few moments. What I've got here is if f of x equals x squared plus 2 all over 5x minus 1. So we can get a numerical answer back. Find f dash or f prime of 2. Okay, f dash means to differentiate, the first differential, okay, of that with respect to x. Away you go. Okay, and we're looking for an answer on that. The quotient rule. It's given in formula books, so I should put it up now for you. Basically, if you've forgotten it, the quotient rule, if you've got what equals u over v, where u and v are functions of x, say, then dy by dx, or f dash x, if this was f of x, is equal to this formula here. Okay, Mr. Bowles coming in very quickly. Iggy coming in with answers. Does anybody disagree with this, or is it going to be 2 over 27? Paul coming in with an answer here. Okay. Interesting. Remember, Paul, I'm looking for f dash of 2. It's going to be a numerical result, okay, so it will not have x's in, okay. Anybody else want to take a pop at what this answer is? Remember, you can always play these videos back when the live stream's finished. The video goes up and you can play it back, pause it at any point, try the questions again, all right? They hopefully make good revision questions for you. Okay, well, we need to wind this up now, and it's good to see that we're getting 2 over 27. 2 over 27 from many of you coming through. That is the correct answer. Well done. Well done. Let's see how we approach this, and I'll show you how I do it actually, okay, for the quotient rule. I tend to think of this as the top and the bottom of a fraction, and this formula, I like to have formulas in words basically, rather than putting it down like this. I find it a lot quicker. What this really is saying is we take the bottom of the fraction, okay, the v part is the bottom of the fraction, times it by the differential of the top, minus the top of the fraction times differential of the bottom, all divided by the bottom of the fraction squared. And if we do that, I'll take you through it, okay? So f dash x equals the bottom of the fraction, the 5x minus 1, is the differential of the top of the fraction. That's going to be 2x, okay? Then it's minus, okay, the top of the fraction, okay, which is the x squared plus 2 times the differential at the bottom of the fraction, which is just going to be simply 5. All right, and then we put this all over the bottom of the fraction squared. Okay, I just find that personally so quick. Okay, I just got to expand this out, or you might just want to put 2 in at this stage. It's up to you. Okay, I've expanded it out though. Okay, so if you expand that out, you're going to get this line. Group up your terms so that you've got fewer terms, and that's going to give you this result here. Okay, and was it Paul who put that in? Let me just check what you put, Paul. Yep, you had it right at that stage. Well done. Okay, and so all you got to do is substitute your 2, and if you substitute 2 into that, you get f dash of 2, and it comes out indeed at either 6 over 81, better cancel down though, as 2 over 27. All right, so okay, so that's good. That is it for today. Just over 30 minutes there. So I'm just going to come back on screen. As I say, you can see this live stream later on. As soon as we finish this, very shortly, it will be processed, and you can go back and review it. Okay. I did ask some of you guys at the beginning, while we were waiting for the live stream to come on, by the way, to enter any topics that you might like me to cover. As I said earlier, just in case you joined us later, sorry to repeat myself here, but Michael is, who's been answering your questions on live chat, is going to be doing lectures next week on Monday, Wednesday and Friday for GCSE Foundation Higher. So that leaves me with Tuesday and Thursday to present a live stream to you, geared obviously for at ASA level standards. So if you've got any topics there that you would like me to do, I can't guarantee I'm going to do them. I will possibly, it will guide me into what I'm going to do. I can see some of you are typing them in now. I see vectors, vector problems, graph transformations is coming up. Interesting, okay. 3D vectors, yeah, vectors seems to be quite popular here. Okay, I'll bear that in mind. As we wind down, you'll have about 15 seconds to 20 seconds when I bring up the last screen to keep typing in, okay, before it cuts off. Anyway, yeah, just to say thank you for coming on board and joining in with this. It's great to see the regulars out there that we see each day. And if you're new to this, hope you got some value out of it. Okay, so going to wind up now and just leave me to say have a good weekend, stay safe, and see you hopefully next week, 10 o'clock as usual with Michael. Okay, see you guys. Bye for now.